Okay, so what we see here is that we've got our North Atlantic current coming in and going under the ice. Now when it gets to those points F and E, it's going to get really cold, and so what we've got is salty, now very cold water, the densest water in the ocean, and what it will do is sink down to the bottom of the ocean, our Arctic Ocean cereal bowl. And once we do that, we'll start filling up the Arctic Ocean cereal bowl and fill it up, and finally it'll reach the top, and that very cold, dense water will flow down into the North Atlantic Ocean and form our North Atlantic deep water. That is the deepest water, or the water that we see on the bottom of the ocean everywhere on Earth. And that sets the great conveyor belt in motion. What we see is the blue represents our bottom water. You can see all bottom water comes out of the Arctic Ocean, flows down, and then spreads across the bottoms of all the other oceans. And then we get upwelling in Antarctica, in the Indian Ocean, and up near the Gulf of Alaska. That deep water comes back up, rides around on the surface, gradually warms up, and then flows back up into the Arctic Ocean as the Gulf Stream and the North Atlantic current, where the whole cycle starts over again. If we put all of our 6 different parts of the model together and take a look and see what happens, how climate change could bring on a new ice age. So here are our 6 parts of the model here. You can just read those. You've seen them before already. And now let's take a look at the model. Here we have a polar view of Earth. There's the Arctic Ocean, our big cereal bowl. And you can see it's got just a few outlets. It's got an outlet into the Pacific, which we know is very shallow because people walked across there during the last ice age when sea level was much lower. We also, it turns out, have very shallow water in here off the west coast of Greenland. And then we have a much deeper ocean out here. However, we have this purple ridge here, which is shallow, fairly shallow water. It's about 1,000 meters deep or so. And that's called the Greenland to Faroe Islands sill, and Iceland sits right in the middle of it. So that makes up part of the rim of our cereal bowl of the Arctic Ocean as well. Now, the Arctic Ocean, of course, is covered with ice, so we'll put some ice in there. And then you remember we were talking about the cold northern winds coming down over the North Pole to form our polar easterly winds, so let's put those in. And what happens when those come in is that those cold, dry winds rush across that Arctic Ocean, and they don't pick up any moisture because it's covered with ice. And then they dump what little moisture they pick up out over the Atlantic, out here at about 60 degrees north, which is at the subpolar convergence. Now let's melt that ocean. We've taken away the ice, and now those same winds, which are dry when the ice is there, they're going to be going across the Arctic Ocean. They're going to be sucking moisture out of the Arctic Ocean. And what that's going to produce is sort of a continuous lake effect on the continents of North America and Eurasia, and of course Greenland too. And what that's going to do in the winter in particular is start dumping a lot of snow. So what happens without the Arctic Ocean there? Well, then we start to cover the continents with snow. And that snow, once it's covered there, is very bright, so that in the summer, the sunlight, remember we've got 24 hours of sunlight in the summer coming down on a lot of this, and that sunlight's just going to bounce back off into space. There's not going to be any opportunity to absorb that in the atmosphere. So what we're going to start to see is we're going to start to cool things down. And as we cool things down, that snow isn't going to melt. It's going to form ice in the summer and the winter. And then what we'll see is a gradual progression, a growing of the glacier, and a return to an ice age sort of situation. In the summer, of course, there is some ice that melts, and that water, that fresh water now is going to drain back into the Arctic Ocean. Fresh water, of course, is a lot less dense than seawater, so it's going to float on top. And what that means is that for the first time, we're going to see water, instead of only exiting the Arctic Ocean through the bottom, surface water will exit the Arctic Ocean over this Greenland to Faroe Islands sill. Now, what does that mean? Let's go back to our original thermohaline model here. And here we'll bring in our exiting fresh water. And now we'll bring in that North Atlantic current. Now remember, the North Atlantic current, when we had ice up here, that makes it into the Arctic Ocean and then sinks down to the bottom. But now that we have this rather light, fresh, brackish water flowing out of the Arctic Ocean, let's see what happens here. That North Atlantic water comes in and it sinks down deep into the Atlantic Ocean. It never gets to Northern Europe, and because it doesn't get to Northern Europe isn't warmed by the Gulf Stream North Atlantic current anymore. And so Northern Europe is plunged almost immediately, and when I say immediately, I mean within a year or two, it is plunged into an ice age. And we start to see the return of the ice building up, particularly, we'll see it first in Eurasia, but it will probably soon follow in North America.